The Ocean Park Station, Wong Chuk Hang Station, Viaducts and Aberdeen Channel Bridge are core components of Contract 903, a critical component of the South Island East project. The scope includes 1,350 metres of viaduct, 2 above-ground stations at Ocean Park and Wong Chuk Hang, and a cast in-situ balance cantilever bridge across the Aberdeen Channel. Leighton Contractors Asia Limited, supported by Flatiron and Meinhardt, has assembled a highly skilled and experienced team to work with the MTRC to deliver this critical and challenging project. As part of the Stage 1 tender, MTRC has requested 7 key method statements. This video describes our approach to these methods. The first method statement involves precast viaduct erection over live traffic. Our approach is to ensure that there will be no erection over live traffic at any point in the project. To achieve this, we propose to use a beam and winch system designed in conjunction with Flatiron to erect the precast viaduct segments. The advantages of the beam and winch include the ability to lift precast segments from along either or both sides of the piers, or mid-span if required. As a result, the beam and winch system has a far smaller area of influence compared to a more typical crane erection method. The beam and winch can also pick up to 11 precast segments from the same location. Coupled with the reduced setup time and ability to deliver modules outside of peak traffic conditions, this all adds up to a construction methodology that reduces the public impact in the form of fewer and less frequent temporary traffic management arrangements. The second method statement involves the erection of the viaduct alongside the police training school. We will also use the beam and winch in this location, lifting 2 precast segments simultaneously on either side of the pier, to maintain the balance effect and therefore reduce any additional rebar required for the out-of-balance effect. The single elevated track will be completed first, followed by the double track. The portion of the viaduct that diverts into the future depot on the east side of the Wong Chuk Hang station will be constructed using traditional cast in-situ methods, supported on a proprietary falsework system. The operation and security of the police training school will be maintained at all times during the delivery of this section of the works. The third method statement involves the Staunton Creek nullah modification works. In analysing the Staunton Creek nullah works, we determined the critical risk to success was the delivery during the first dry season of the piles and pile caps, nullah modification and widening works and decking, necessary to begin construction of the Wong Chuk Hang station. Our construction methodology reduces the size and scale of the decking works by using small temporary decks, allowing us to create more work fronts across a total of 14 piling machines. The decks will be sufficiently high to allow us to work in all weather and tidal conditions, thereby reducing risk to the program. We recognize that works on the nullah base can only be completed during the dry season. We will deploy additional piling resources to ensure the essential work elements are all completed within the first dry season, and the constraint on the subsequent station works is removed. The fourth method statement involves the Nam Long Shan Road Utilities diversion and associated traffic management. During our Stage 1 tender process, we developed a comprehensive sequence of utility and traffic diversions at the sensitive Nam Long Shan Road junction. The sequence was developed using internal resources familiar with the local area and community who are currently working at Ocean Park. Our proposed solution is to complete a section of the permanent deck where the envisaged temporary deck was located, thereby eliminating an entire sequence of works, including building, demolition and temporary structures. This improves both time and cost for the MTRC. We recognize the need to divert the 2 rising mains at Pier D1B as early as possible. This will allow the commencement of board piling in the first dry season in order that 8 board piles can be completed, and nullah decking can be constructed. We also recognize the 2 gas mains need to be temporarily diverted to the new nullah deck, which enable temporary road diversion for the bridge demolition to start in the second dry season. The sewer and all temporary utility diversions will be permanently relocated through C4 and the final road layout constructed towards the end of the project. The fifth method statement involves the construction of Wong Chuk Hang Station. The erection of Wong Chuk Hang Station will be a combination of in-situ and precast construction. We propose that the primary and secondary beams and slabs for the concourse level, platform level, plant room and roof levels be precast and semi-slab constructions as much as possible. The main and secondary beams will use precast U or L shells. This will reduce the on-site concreting and associated traffic by approximately 800 truckloads, with follow-on benefits for safety and community impact. Further benefits of the precast solution will be reduced falsework and risks associated with working at height. We have found from experience that precast construction offers the MTRC a more consistent and higher quality of finish. This will enable the reduction of follow-on wet trades and bring associated cost and time benefits. The sixth method involves the Staunton Creek Viaduct construction from Nam Long Shan Road to the Aberdeen Channel Bridge. There are two key areas of risk in this section of the works. The first is managing the impact on the area around the cooked food market and the Tai Wong Yi Temple. The second is managing the impact on the Holy Spirit Seminary and the Hong Kong Jockey Club Rehabilitation Centre, located on top of the slopes adjacent to the viaduct alignment. In conjunction with Flatiron, we have developed a side slider beam and winch that allows us to erect segments over the cooked food market and adjacent to the Tai Wong Yi Temple with a minimum of traditional crane use. We plan to erect segments outside business hours of the cooked food market, thereby minimizing community and business disruption and protecting the MTRC's reputation as a good corporate citizen. In conjunction with Flatiron, we have developed a straddle crane to be used from piers D13 to D18. Straddle crane will be used to perform and support all operations, from bench support and foundation installation through to superstructure erection. Straddle cranes allow us complete flexibility to work along this section of the viaduct without the need for large temporary works platforms to support heavy cranes at the top of slopes for the foundation works. To overcome the limited access to the area, all materials and equipment required for this section of the works will be delivered via the straddle crane from a pickup point between piers D13 to D14. This approach minimizes the need for large, expensive gantries requiring significant mobilization times, thereby saving time and cost for the MTRC. The seventh and final method involves the in-situ construction for the Aberdeen Channel Bridge. For the bridge construction itself, we propose to use precast shells for both E2 and E3 pile caps, which will be towed in and tidal lowered over the already installed pre-board piles. This will remove the need for a sheet-piled cofferdam, eliminating the vibration concerns on the existing road bridge, improving quality of finish and reducing contaminated material disposal. For the bridge pier construction, we will use a proprietary jump form system utilizing cast in-situ construction. This will provide short pour heights, thereby reducing safety risks and increasing the quality of finish. Our proposed method allows for a larger than normal pier table onto which the travelling forms will be installed. This has the benefit of the pier being only a half section out of balance rather than a complete section, thereby reducing the amount of rebar required in the pier and potentially reducing the size of the foundations. Leighton, supported by Flatiron and Meinhardt, is ready, committed and able to deliver Contract 903 in a collaborative, high-performance partnership with MTR. This Stage 1 response is just the beginning. It is our first step in our journey with MTR, working for the successful delivery of Contract 903.